Okay, this is the last part of this chapter on potentiometer here. Potentiometer is actually a device used to compare or measure potential difference or EMF of a source. It's like a voltmeter in that sense. The advantage is that it doesn't draw any current. So that's the main thing you want to keep in mind about potentiometer. It does not draw any current from the circuit that it is trying to measure. Okay, so it's like a voltmeter that doesn't draw any current without drawing any current. Unfortunately, it is very bulky here as shown here. So it's not as convenient to use, even though it can give you more accurate answer. If you remember previously, we know that voltmeter has got problem because it draws some current from it, therefore measuring a value that is a voltage value that is slightly less than the true value. We can get a more accurate answer using potentiometer when it doesn't draw any current from the potential value that it's trying to measure. So how does this potentiometer work here? First, it has got a very long wire, resistance wire, which is bare and uniform in cross-section area. It's uniform in cross-section area. Okay, so that means the resistance vary uniformly along the length. So R is proportional to length. Remember this equation is rho L over A. So it's A is constant, rho is constant, so it's proportional to the length of the wire. The resistance is proportional to the length of the wire. Now there is also a driver cell. You need a driver cell. This driver cell keeps the current going in the resistance wire and provide potential for comparison. And apart from that, you also have a galvanometer. Okay, this is not correct here. This is not correct. Okay, there's one more galvanometer. Now, this galvanometer is sometimes called a null meter. Okay, if you look at the symbol here, it's a pointer. It's a needle showing sort of pointing at the center when there is no current. If there is a current flowing one way, the pointer is going to swing one way. If the current flows in the opposite direction, it's going to swing the other way. Okay, so when there is no current, the galvanometer actually settles down at the center position. And in fact, this is the purpose of the galvanometer. A galvanometer is basically a sensitive ammeter, but its function is actually to detect no current. Okay, I repeat, it is actually a sensitive ammeter whose purpose is to detect no current. Right, let's see how it works here. Firstly, this part is the unknown that you're trying to measure. This part is the unknown voltage. The part, everything else on top here is the galvanometer. So this whole thing here is the galvanometer, is the potentiometer. So imagine this whole thing is like a voltmeter, a very huge voltmeter. Okay, let's see how it works here. Remember that if you connect resistance wire, a long resistance wire to the EM driver cell here, the PD across this will depend on the length where you tap this point, where you connect to this point to. If you connect the full length, you get the entire potential between one end to the other end. You get the E here. If you connect at the halfway, you get half E, the PD. If you connect this point here to this point, you get half the PD. So the purpose, the idea behind this is that you put the unknown voltage at the bottom, then you do by try and error, you move this point around by try and error. Tap along here, you start maybe from here, you tap here, you find that there's current flowing through the galvanometer, and this is not the correct position. You move it away, move and slide, move along here until a point is reached where the current passing through the galvanometer is 0. Okay, this is how you operate a potentiometer. The sliding contact is moved along the wire AB until you locate a point where the current flowing through the galvanometer is 0. And at that point, you take down the length of the wire on the resistant wire, which in this case maybe you call it L1. Okay. Now, when that happens, when there is no current flowing through the galvanometer, you say that the potentiometer is balanced. Why is there no current passing through? Remember, current flows because there is a potential difference. Current flows because there is a potential difference. Now, if there is no current, it means that the unknown voltage, if this point is the point where it's balanced, is I call it C. If there is no current flowing through the galvanometer when the sliding contact is at point C, it means that the potential between AC is the same as the external potential, the unknown potential V. Okay, so that's the logic behind identifying the unknown voltage. Now let's look at the circuit above. If the potentiometer is balanced at length L1, then the PD of the unknown source can also be calculated from the ratio of the length. So the whole length has got a potential of E. This is the entire length, the whole length. The whole length of the potentiometer gives you a potential total PD of E. So if my unknown voltage balanced at the length of L1, its potential should be proportional to the length L1. Okay, this is a potential divider formula which we learned earlier. Now, in order for the circuit to work, the value of E must be greater than the unknown voltage, the driving potential. So maximum potential that you can measure is E. Okay, so E is like the maximum value of a voltmeter range. The next thing is the potential, the polarity of the unknown voltage and the driver cell must be in the same sense or same direction. So if this is the way I connect it, and this is the unknown voltage, the positive side and the positive side must be connected to the same side. So this is the positive end must be connected to the same side. On the other hand, I could have reversed it, and my unknown voltage must also be connected in the reverse way in order to get a balance point. Now, if you do not connect it properly, for example, if I do it this way, I connect it this way, and I try to find a balance point. No matter how hard you try, you will connect here or connect to the other end. No matter how hard you try, you can never get a balance point. So this is wrong because the polarity has been reversed. Okay, we'll look at more examples to understand how the potentiometer circuit works. Let's look at a simple example here. Okay, so the circuit shown here, the unknown is here. This is the unknown. This is what we want to find out. Okay, the EMF of the unknown. And the potentiometer, as I said above, is this part here. This part is the potentiometer. So we're trying to measure the unknown voltage using the potentiometer circuit. First of all, you're told that the balance point is at point B, which is the length of 0.65 meter out of 1 meter. This whole length is 1 meter. So the total resistance of 60 ohm from A to C when divided by section AB is actually according to the potential divider or resistance proportionality equation, R equals to proportional to L. So the whole length is 60, so 65.65 meter will have a resistance value of 39 ohm. Okay, so this is 39 ohm. So what is the PD of AB? Equals to VAB. The EMF of the test cell is actually equal to, when there is no current flowing through the voltmeter, the EMF of the test cell or the unknown cell, this is the test cell or the unknown, is actually equal to the potential at AB when no current flows through the galvanometer. So instead of calculating the unknown voltage, I just need to calculate the PD across AB. The PD across AB is simply calculated from potential divider formula. This is the potential divider formula. And that gives you 5.85 volt. Now you notice that there is an additional 500 ohm resistor in series here that we are not using here. This particular value. Now this 500 ohm here does not affect the balance point, because when there is no current flowing at balance point I equals 0, whether you have 500 ohm, whether you have 50 ohm, whether you have 0 ohm, the PD is still the same when there is no current, because there is also an internal resistance of 30 ohm here. So the PD from here to here, if I call it V is in general the EMF minus I 30 plus 500. Now because my I here is 0, so this whole term can be cancelled out. So effectively I can measure the EMF of the unknown value. So the EMF, which is V, this EMF that I measured, which is equal to VAB, is effectively the EMF of the battery. So this is an example of the use of potentiometer, where it can be used to determine the EMF of the unknown voltage, even though there is an internal resistance in the unknown voltage. Now this cannot be done using a normal voltmeter, because a normal voltmeter will draw some current, will have a small current here, and you'll find that the V is slightly less than E, whereas a potentiometer overcomes this problem because it does not draw any current from the circuit that it is measuring.